With photonics being pivotal in the next-gen data transmission, what's an intriguing example of how this might change our internet experience in the near future?
Now, there was a time there are a very few services and apps or the companies are available who will providing video calling. But nowadays, calling by video, that's a very common feature we have. Now the entire world is shifting towards the high-speed data communication. So with the cable communication, there are a limitation you have that you cannot go beyond the gigahertz frequency. But with the optical fiber, it is working on a terahertz frequency. So we can say it is a 1 million times faster than the conventional cable technology.
How does photonics blend with biology to create solutions for health and medicine?
So over a period of time in biomedical engineering or in sensing technology, that photonics already has been involved. Like whenever the doctor will give the prescription about scanning the body through X-ray or through any type of the machinery they are using, it is nothing but it's a photonics technology.
Welcome. And joining us today is Dr. Vishal Sorathiya, who is an assistant professor and researcher at the Department of Electronics and Communications Engineering. Sir, thank you so much for joining us today. So before we delve into the questions that I have for you, may you please give us a brief about yourself?
Thank you very much, Kuda. If I'll give you the brief about myself, so I have completed my bachelor's, master's, as well as in a PhD from electronics and communication. And I have dived through the topic which is related to photonics. So my PhD research was on a graphene-based polarizer device. So this graphene-based polarizer device actually used to manipulate the light, especially the far infrared light, which is working from 1 to 10 terahertz. And it is having applications to polarize the light in different angles, which is ultimately used for the spectroscopy as well as for the sensing. During my PhD duration, I have also explored with the numerous devices like biosensors are there, solar cells are there, optical fiber cables are going to be there, polarizer are there. So along with the polarizer topic, I have also experience with the multiple photonics device, which will use for biomolecule sensing, for the gas sensing also, to increase the efficiency of solar cell also. And our team has got a numerous amount of the publication which is on Nature, Springer, and our team has also got a chance to visit some of the reputed conferences in US. So this is all about research that we have done and during my PhD studies. Me and my team, yeah.
Thank you, sir. Now that we've gotten more acquainted with you, sir, could you please illustrate how photonics, often seen through the lens of physics, is making unexpected appearances in everyday technology?
Yeah, so actually we are surrounded by the photonics devices, by knowingly or unknowingly. We are using photonics devices. This word is look like some fancy word, photonics. Actually, not a major person is aware about it. But if we talk about some simple term, like let's say display devices are there, our TV remote control are going to be there. So TV remote controller is one of the example of the photonic device, which is having some LED to throw the signal to the TV and you can control the device are there. Similarly, what are the electronics gadgets are there who can control by the remotes? That has made up through the photonic device, and which is named as LED. As well as if we can say the display technology. So whatever the high quality display we are experiencing as of now, televisions are there, computer screens are there, mobile screens are there. So how we are getting such type of the high quality images, it is only possible through the display technology or pixel technology available in this display devices. So ultimately this photonic devices or entire photonic technologies associated with the three part. Let's say what are the sources of light, what are the device through which we are controlling this particular light, and what are the detector are there. So actually whatever the communication we are doing in a general, we are having electrical signals are there. So if we talk about that, our mobile phone or our TV control, TV remote control we can say. So it is having a electronic signal which is passing through that particular circuit, but ultimately we are communicating through the light. So our half part is related to that, how we are generating a light from electronic device to the photonics, and later on how we are controlling those flow of light, and at the end how those light has been detected, and again it will convert into the electronic circuit. So basic photonics technology and entire research domain are associated with this three step. Either you are working on a better type of the light source, or you are working on a better type of the light detector, or you are working on an intermediate device which actually going to manipulate this light for a specific application or for the specific type of the environment. So this is a all and all photonic basic phenomena we have. So yeah, we have several number of devices available to us which will very useful in our day-to-day life.
Okay, that is very interesting, sir. And furthermore, with photonics being pivotal in the next-gen data transmission, what's an intriguing example of how this might change our internet experience in the near future?
Yeah, so we very much used to communicate through the video call nowadays. Now there was a time, at the time there are a very few services and apps or the companies are available who will providing this video calling. But nowadays calling by video, that's a very common feature we have. And if you can consider right now that if I want to talk with my friend in US, which is another end of this particular this particular earth. So over here from India to US, there are 18,000 kilometer distance are going to be there. But you have experienced the same high-speed communication technology that within a 1 or 2 second you are getting your communication from here to there, and they are responding back within a 1 or 2 seconds. It will take. Meaning of that, within a 2 second, whatever the word, whatever the speech, or whatever the video you are sharing, it will go over there and the response are coming back from the same distance. So this is the possible only and only because of the fiber optic technology currently available with us. There are a age where we are using cable communication. Right now also we are using cable communication, but now the entire world is shifting towards the high-speed data communication. So with the cable communication, there are a limitation you have that you cannot go beyond the gigahertz frequency. But with the optical fiber, it is working on a terahertz frequency. So we can say it is a 1 million times faster than the conventional cable technology. So that fiber optic cable, that 5G and 6G technology, which is integrated with the fiber optic cable, and upcoming generation, which will going to be the very breakthrough for the high-speed communication, and as well as which is essential requirement for the current society because our data consumption are going to be very high. So people are required very high data availability to share their detail, photo, Instagram, social media, which is required at very fast speed of rate. So this photonics technology, specifically the fiber optic communication, which is the only solution to achieve such type of the requirement of the society. So yes, this photonics technology plus fiber optic communication will definitely solve the problem or definitely satisfy those requirements, which is actually now much needed in a current technology or in a future generation of telecommunication.
This is indeed intriguing, sir. How does photonics blend with biology to create solutions for health and medicine that were once considered science fiction?
Yeah. So over a period of time in biomedical engineering or in sensing technology, that photonics already has been involved. Like whenever the doctor will give the prescription about scanning the body through X-ray or through any type of the machinery they are using, it is nothing but it's a photonics technology. So what are the rays they are using? UV rays or X-rays or infrared rays they are using to scan your body or to detect some of the cells from some biomolecules, which is actually a photonics technology that people are already using. But what are the upcoming requirement and challenges are there? With the photonics technology, whatever the conventional sensing technology or conventional solution are there, which will improvise their efficiency or sensitivity at some next level or at the large. Now, how it is going to be possible and what are the requirement of that? So, for any biological sensing, or we can say biological measurement related application, we need to design a optical sensor. And it's not only the optical or photonic sensor, but yes, it is integrated with the current electronics technology also. Like that we can know as a optoelectronic sensor, as well as it will chemical sensor, which is also now integrated with the photonics technology. So what we required that currently people also working in very vast research area on this one. But what is actually the requirement that how light is going to be affected on different type of the biomolecules. Let's say you are taking a basic example of that. You have the hemoglobin samples are there, you have a urine samples are there, blood samples are there. So how light is going to be affected at the I can say molecular level or into their specific property. So by analyzing these changes, by imposing the light in that, if we can detect those changes, we can also detect the I can say changes in that particular biomolecules. So ultimately, by using a light, we are superimposing on such biomolecule sample, and which will result into some of the chemical composition, or we can say in some type of the their molecular composition. We ultimately detecting that how this biomolecules are going to be changed. So this is a one part of designing a sensor through photonics devices. In other sense, also that people now looking for very rapid diagnostic type of the kit. Like we can say in medical, people need a doctor at their own place. So through the fiber optic communication, yes, we have the sensor network we have around the surrounded by that particular area. Let's say right now we are using Alexa also, we are using some of the voice assistant devices also. And this is connected through our nearby Wi-Fi hotspot. And then later on it is connected directly to the doctors or to the particular physician. So that biological, or we can say biomedical engineering or the medical science is now coming to your particular place. And you need not to go to one particular place and you need to do the diagnostic. Through this photonics technology, through this high speed communication, and through such type of the sensor and measurement devices, we can experience the same type of the facility at our place. So yeah, this is possible, but still people need to work more on sensor development, as well as to develop the detecting device are there, because gigahertz technology has been reached to their particular peak in terms of detector and all. But with the terahertz, there are still lots of research is going to be happen, because people are working on a material, their interaction with the devices, their sensor part, their detector part, their light generation part. So once entire channel is going to set, and very tiny and we can say very handheld device are going to come into the market. So we can be more and more accurate in terms of sensing and in terms of biomedical field also. So that's the possible through the photonics technology.
Okay, so basically you've walked us through the ups of photonics. So now will you please tell us what's a surprising challenge that photonics faces, and how does drawing knowledge from other disciplines help tackle it?
Okay, so photonics, which is applied in every engineering field as of now. Let's say for chemical engineering also, for the civil engineering also, for the biomedical engineering also, mechanical engineering also. That photonics technology is applying to every sense of engineering field. So there are no restrictions, first of all, that this field cannot solve the problem of other field. That's not at all the restriction nowadays. But challenges nowadays is related to how those conventional technology replace with the light. Okay, because what are the first part when we are designing any type of the photonic devices? We first need to create a entire channel let's say today I have created some device which is working on photonics, or we can say light sensitive structure are there. So for that I required a light source, detector also, and the device itself also. Now if we are going to talk about that some handheld device, let's say some electronics device are there. I'll take a basic example of some I can say a glucometer are there, or we can say some heartbeat monitor device are there. So some handheld device that can directly connect through the body, and on the same place you are detect those particular parameter. So such type of the handy devices are there. But why it is working very I can say promising in nowadays, because everything which is embedded on a same place, whether it will their battery, their source, their data acquisition module, their microprocessor chip, everything is going to be embedded on a same size. But when we're talking about the photonics, so we are claiming at the time that whatever this parameter are there, we are detecting through the light. So we need to set up a such type of the channel which will generate the light, detect the light, data acquisition, and all type of those measurement structure are onto the same place. Now to integrate this photonics technology into such a small place, there are still the research are going to be in an exploring stage. And the reason behind that, because there are lots of two-dimensional material, there are some nanomaterial are also associated with that, because that LED itself, if you're talking about the smallest part, it is made up from some nanometer size or micrometer size of the silicon structure. So to create such miniature device and integrate all of them into the one place, which will fulfill our task, which is going to be the challenging part, and selecting a proper material to do that. And it is reached to the expectation, testing, verification, their aesthetic look, or we can say their acquisition control device, associated electronics device. Once we can go with this entire channel, if we can fit into one place, so whatever the current device are there, we can replace with the photonics device also. But yes, people are working on that and facing this challenge also. But soon we can experience such type of the handheld device also, which are working on photonics technology.
Okay, sir. So my last question for you today. Photonics has a role in environmental monitoring. Can you share a captivating way it helps us understand our planet better?
Yes. So as I have told you in my previous answer, that there are sensor technologies are there, which is very much in popular field right now. If we take the example of temperature sensor or humidity sensor, which is a very common sensor used for any type of the environment measurement, as well as there are a sensor related to some agriculture related field, like you are sensing some soil, or you are sensing such type of the behavior of one particular area, or we can say weather forecasting through some particular devices. People are working more on this sensor development, which will applicable for weather forecasting, for the agriculture material sensing, as well as basic humidity or temperature sensing. And people are now working on that, how the accurately those sensing technology are going to be achieved. And as I have told you, how those multiple sensor can integrate into the one place, and we can give the quick decision, and we can give the quick solution out of that. For example, if I'll say there are a project that people are working on integrating all type of the soil sensor into one particular device, and it will transmit their data to the clouds. So what are the previous technology that you need to bring that soil to one laboratory and you need to test that and give the report? But through the photonics technology, people are working on that, how we can detect those all the characteristic and all the parameter on the ground, and you can directly get the data into the cloud. So such type of the fascinating projects are there, or field are there, which going to be the possible solution of the next environment monitoring and related to sustainable development also. Yeah, that's also the possible to the photonics technology.
Thank you so much, sir, for intriguing and enlightening us on photonics technology.
Thank you.
Thank you for joining us today, and thank you for watching.